Hi, welcome to Conversions Between Mass and Moles, part 2 of 2. In part 1, we looked at several examples where we showed you these types of problems and you tried a couple on your own. Now what we're going to do is we're going to go into some CFUs, just 5 CFUs, which will help you are designed to help you avoid common mistakes and identify key things to consider when solving these problems. All right, so as I said, there are 5 CFUs, and after each CFU, you'll have a moment to pause the video and try to answer it on your own. Before you press play again, the answer is revealed. All right, here's the first CFU, true or false. 1 mole always goes in the numerator of the conversion factor. Explain. So when solving these problems, do you always put 1 mole in the numerator on the top of the conversion factor? Try to answer this question on your own. Pause the video now, and when you press play again, the answer will be revealed. Great, that's false. And that's false because it all depends on what you're starting off with. So in the case where you are starting, when you're converting from moles to grams, in that case, in the conversion factor, the 1 mole is going to go on the bottom of the conversion factor, so in the denominator, to cancel out the moles. And you can see that in part 1 of this video in examples 2 and 3. CFU 2 is also true or false. So true or false for the question, how much does 2.38 moles of dry ice weigh? Put the start over 1 mole to cancel out the units. All right, so you're going to try and answer this true or false. Pause the video now. When you press play again, the answer will be revealed. That answer is also false. Remember, whatever you're starting off with, you're going to put it over 1. Just 1, not 1 mole, just 1, to make it into a fraction. Just like you're making any number into a fraction, you put it over 1. There's no unit after the 1 for the starting fraction, so just over 1. However, it's important to note that in the conversion factors for these problems, you're always going to have a 1 mole. So the conversion factor, so you put the 1 mole in the conversion factor. It may go on the top, it may go on the bottom, depending on what units you're trying to cancel out and keep. So, so this is false. Let's try CFU 3. Which of the following equations should be used as the conversion factor for the question? Question shown below here, and explain. How many helium atoms are in a balloon containing 0.33 moles of helium? So you're going to try and pick the correct conversion factor and explain your choice. Pause the video now. When you press play again, the answer will be revealed. Answer C, and that's because in this example we're converting from moles, 0.33 moles, to number of atoms. And remember, whenever you're trying to convert from moles to number of things, you're going to use Avogadro's number, 6.02 times 10 to the 23. And so remember, 1 mole contains 6.02 times 10 to the 23, whatever it is, whether it's atoms, moles, molecules, or peanuts, doesn't matter. 1 mole is equal to 6.02 times 10 to the 23 things. All right, let's try the next CFU. Which of the following equations should be used as the conversion factor for the question below, and explain. So how many grams of helium are in a balloon containing 0.33 moles of helium? This sounds very similar to the previous question, but a little different. So if you may need to read it again on your own just to sort of figure it out. Pause the video now. When you press play again, the answer will be revealed. Great, the answer is choice D. And in this case, we're converting from moles to grams. So in CFU 3, we've converted from grams to number of atoms. Here we're converting from moles to grams. So when we're converting from moles to grams, we use 1 equals the molar mass. And the molar mass for helium is 4 grams, which are shown at the bottom here. The 2 is, if you're using this number, that's incorrect because that's the atomic number. It tells you the number of protons. So you got to use that decimal number, which is the molar mass. All right, last CFU. So it was asked you to identify and correct the mistake, and I'll show you the work in a moment. Let's read the question first. How many grams of helium are in a balloon containing 0.33 moles of helium? All right, so here's the work here. Start conversion factor and End. All right, so identify what the mistake is and then correct it. Pause the video now. When you press play again, the answer will be revealed. Okay, so in this case, the error is in the conversion factor. So let's take a look at that conversion factor there. We know 1 mole of helium is equal to 4 grams. And since we're starting off with moles, we definitely want the moles to be in the denominator so they can cancel out. However, if you take a close look at our conversion, our equation that we're going to get the conversion factor from, the number 1 is in front of moles, not 4. So these values got switched. And so that's the error that was made here. The values in the conversion factor were switched. Now, once again, it may be helpful to sort of keep in the back of your mind, in your conversion factor, you're always going to have a 1 mole for these sort of problems because we're setting all of our molar masses equal to 1 mole. So 1 mole must be here. So if you look in your conversion factor, you see that the moles, the value does not have a 1 in front of it, you probably made an error somewhere. All right, so here's the correct work. We're going to keep the units where they were because the units were fine. It was just the values. So we just switched the 1 and 4. So this will be 4 grams over 1 mole. And then that leads us to multiplying these two values and then giving us the end value of 1.3 grams. All right, so that's it for these problems. You have a series of practice work to do before you take your exit ticket. Hope you found this video helpful. Have a quality day.